Here again with my brother, Dr. Matt Catterman.
Hello.
And I'm Frank Catterman, and we're the agricultural engineering and climate change brothers.
Energy.
Oh, energy, yeah.
Yeah, it's
energy,
that's the same thing, yeah. Engineering is the...
Well, we're both engineers,
yeah.
so, yeah. And with us today also is the author, Matthew Catterman, of Biofuels Manufacture from Renewables Other Than Corn Starch. So that you wrote a while back, about 7 years ago or so. That was back when this big biofuel thing was going on. They were trying to take all the corn and use it to make ethanol and stuff, right?
We're still doing it.
Yeah, I know, it's what a mess. But but you were ahead of the curve trying to tell everybody, hey, it doesn't make much sense to take a food product that we probably need and make it into a fuel product. I mean, there's many other better ways to do that than taking a source like corn away from the market. But anyway, so unintended consequences there, I think, certainly was happening. So, all right, so we've talked a lot about climate change and definitions and what it is, what a greenhouse gas is. Talked about laws and talked about legislation, things like the Paris Accords. We've talked about becoming net zero, what that means. So there's a lot of things. We've made a lot of terms and introduced those. But today we're going to talk about something called decarbonization, because that's really the next step after you look at all these things that we're doing. You have to reduce your carbon. You have to get it out of the atmosphere, and that's or CO2. We're talking about carbon dioxide mainly, and or greenhouse gases. So you really have to, in order to make progress as the world gets larger. The world's not getting larger, but more people on the earth, more people burning and using energy. You have to reduce that amount so that we're making progress towards less greenhouse gases in the atmosphere. So decarbonization, we've split it up into two terms, or two methods. And one is just simple reduction by using efficiencies or engineering practices, best practices to reduce the amount of carbon you're putting out. So simple example is, you got to go to the grocery store, buy a loaf of bread, you walk there, you ride your bike or something instead of driving your car. You're now not producing or emitting the greenhouse gases that you would have if you drove your car. That's a way to reduce your CO2 output, right? That's a simple example. There's another one we talked about where, like a little more complex, a little more, is fleet management. When a company has a fleet of vehicles, they need to maintain these vehicles. If they're poorly maintained, if they have low tire pressure and they're not tuned up often enough, the oil changes don't come when they should, the car is going to run less efficient. It's going to get less fuel efficiency. And so therefore, now you're producing more greenhouse gases. But if it's properly inflated tire pressure, if it's tuned and efficient running, then you're going to, in driving the same amount of distance, you're going to do less carbon emissions because you have better fuel efficiency. So that's another simple example of reduction. The way to decarbonize by reducing your practices that you have now. So,
all right.
So, the second one that we're going to talk about in decarbonization in that category, a little more complex. It's called sequestration. Sequestration, not just sequestration in the sense of economics. It's sequestration and carbon sequestration. So that implies taking carbon out of the air and capturing it and storing it and maybe doing something with it, right?
Mm-hmm.
So what's an example of sequestration that you can think of?
Well, for example, at power plants, instead of when you combust like coal or natural gas, instead of it going out of the stacks into the atmosphere, you can put it through equipment called amine scrubbers. They're chemicals that they absorb the carbon dioxide and they store it, and then you treat it like with heat or something else, and then it releases that carbon dioxide. And then you can take that carbon dioxide and compress it, and either pipeline it somewhere, or you can put it underground, or you can compress it into supercritical carbon dioxide, which is more almost like a liquefied form. And then you can use that later on.
Where you put that in tanks. You
Or you
store
put
that
it in tanks, yeah.
Like you see those big cylinders that
Yeah.
you can have CO2 in, and that's sort of like they're steel cylinders, and you have the little gauge on the top. And
Yeah.
that's a way to transport and to store carbon dioxide, right?
Right.
Okay. Well, there's two methods of capturing carbon dioxide. There's the air capture, which taken directly from the air out of the atmosphere all around us, and there's the flue.
Which is what I was talking about earlier.
Right. The one you gave was the flue.
Yeah, the other one that we're going to talk about is the direct air capture. And so a lot of people know of the system that kind of Bill Gates is.
Yeah, what's he doing? What's he making?
Well, I think it's like a facility that has a lot of fans, and these fans take in the air and then they kind of compress it and they remove the carbon dioxide from all that air.
But what's he making?
I think they want to make jet fuel out of it.
Okay, so he's doing something with this carbon dioxide he's capturing, right? So
yeah, they're doing something with it. So it's called the carbon negative process. Well, eventually it gets reused anyways, but it's carbon negative because you're not generating it; you're taking it out of the atmosphere.
Right out of the air.
Instead of generating yourself and then capturing it, so that's why it's a negative.
Okay.
Instead of like neutral.
All right. So yeah, we have the air capture, direct air capture, and then we have the flue. Like in the flue of the factories where you take it before it gets in the air. Those are sort of the two methods that we're talking about for sequestration or carbon capture.
And part of that is you have carbon capture and storage, sequestration and storage, but you can also have carbon capture and utilization. So I guess like the storage when it's supercritical carbon dioxide you can use in industry, or you can use it directly from those power plants into making chemicals. But either way, you're utilizing it again,
right,
to make in manufacturing. So for example, it could really be used in industry, the supercritical carbon dioxide, because it's effective as a solvent, which can be used in a lot of different manufacturing areas, which we'll get into later.
Yeah.
But that's the good thing, you could make methanol with the carbon dioxide if you had that too. So that's something else we'll talk about. But yeah, there's things like that,
Well, yeah. So using it is a good thing instead of just putting it in the ground. That's not a bad thing. Putting it into the ground, it's okay because carbon dioxide's in the ground anyway.
The main reason they do that is to do enhanced oil recovery. So most of the projects that do carbon capture and sequestration, they put that carbon dioxide back into the ground and it mixes in with the oil underneath the ground, and they re-extract it out again.
Right. So then they just capture it again and do it all over again, right? So it keeps cycling that CO2 back into the ground and then they capture it again, right?
Yeah.
So for oil. Yeah, crude.
Crude, yeah.
So okay.
It's a better step than just taking it out of the ground and not doing anything about it. So it's a step in the right direction.
Right. Okay. So great. We'll talk more about some of these methods.
Oh, hold on. I wanted to
Go
talk
ahead.
more about this stuff. So some other areas of which we can really do with the reduction is in the transportation sector. So we can do this as far as we have the electric cars, but I think that's not the only way. We shouldn't put all our eggs into the basket of using the electric car to solve our our emission problems. We can use different types of cars and different measures with the cars to improve that situation. For example, we can even do sequestration on the cars themselves. There's a company doing that where you remove the carbon dioxide
right out of the tailpipe,
right out of the tail before it goes back into the atmosphere.
Right.
So you can do things like that. The other thing I was talking about is with manufacturing the fuel itself. So if you use biofuels or if you do direct air capture to make your fuels, you're removing that extra carbon pool, which we call anthropogenic, but it's coming from underneath the ground. And that's not the way nature usually uses carbon and recycles it. That's something that we kind of started doing. So we're taking that out of the equation, and then we're just kind of doing more of a carbon neutral process where we're extracting it out of the air, or we're using like plants or whatever from the carbon dioxide and then turning that into fuel. And then So it emits if we do it right, it emits less carbon overall, and it doesn't use the carbon out of the ground. Also, I wanted to talk about reducing through recycling, reuse, or refurbishing, which they kind of term as the circular economy. But that's really the best way to do it. If we recycle, we prevent emissions coming out of the first place. Say, for example, in the landfills or places like that.
Right. Those are things. To me, there's a lot of ways we could reduce that everybody's capable of helping out with. Recycling is one of those things that we all can do, but we're just not doing a very good job as a country in recycling right now. So if there were government programs that would incentivize more recycling, I think that would be worth money well spent in doing those type of programs, because it would certainly reduce the CO2 emissions out of our landfills, and it would certainly, and especially in the metal recycling, it would reduce our need to have to produce raw metals from mining them out of the dirt in the ground, such as aluminum. That would save a lot of power doing that, which again converts into CO2 emissions. And so a lot of things we could do that we're not doing right now, but I think what I call the low-hanging fruit that would be very efficient and easy to do.
Also, with the manufacturing methods themselves, we could not use conventional technologies that we're using right now and substitute them for new ways or technologies of making things, such as our fertilizer. We could do our fertilizer a bit better, and making fuel like we were talking about, and other chemicals. So things like that. So we'll talk about those later.
So yeah. All right. Anything else on the subject before we get into the deep parts of it? Okay.
Yeah, that's good.
All right. So so stay tuned for more decarbonization discussions about some of the things that we're seeing on the horizon, and some that are good practices and that we think should be pursued, and some that maybe we're not being so well implemented about it. So we'll find out a bit more about these things as we discuss them.